So number 4 talks about these full carton of eggs. So 1 randomly selected cardboard container, 12 randomly selected eggs. The weights of such full cartons are approximately normally distributed. We have this mean and standard deviation. So that's all I've summarized here. A full carton is approximately normal, 840 and 7.9. I'm trying to find the probability that a randomly selected full carton of grade A eggs will weigh more than 850 grams. So I'm going to envision this normally distributed shape. The center is about 840. We have a standard deviation of about 7.9. And I'm trying to find the probability of being more than 850. So, and these are again, not egg weights. This should be carton weights. I just want to label it just to make sure it's clear that these are not z-scores, even though that would be an obscenely large z-score. So, this probability of, how do I want to write this up? I'm just going to use C for my carton being more than 850. I'm going to use my normal CDF to find my area, with the lower being 850. The upper needs to be positive infinity. I think 1,000 is probably large enough. 850 is pretty large already. Maybe I'll put 10,000 just to make sure. I have a feeling it won't matter, but I don't want to be wrong. Standard deviation is 7.9. Okay, so when I put that in my calculator, I get 0.1028. So a little over 10% of the time, we should expect to get a carton that weighs more than 850 grams. If I want to estimate the 70th percentile of full cartons, so I'm still looking at this full carton summary here. So I am still going to think of a normally distributed curve. So I'm actually going to just steal this one. But now I know that there's this some odd number. I don't know exactly where it is. I'll call it X. The area below it has to be 70% of the curve, because that's what a percentile is. It's the value below which 70% of the area falls on or below. So I'm going to say that the probability that my random variable C is less than or equal to just some number that I'm going to find is 0.7, so I can find that using the inverse norm. So I'll have to tell it the area to the left. Now, since I'm saying I'm finding an X value, I will not use 0 here. I will not use 1 for my standard deviation. I'm jumping right into an X value. I will use the specific distribution's mean and standard deviation. So I got about 844 from this one. This should be grams. Below that value will be 70% of all full egg cartons. Full egg cartons less than 820 grams are deemed too small to sell. What proportion of full cartons will be labeled as too small to sell? So yet again, I need the same exact distribution. Oops, not that. So this is below 820, so that's more than 2 standard deviations away. That's going to be pretty unusual to happen. So I'm trying to find the probability of a full carton being less than 820 grams. So this time, my lower, I'll just throw in negative 1,000. And I shaded from negative infinity until I stopped at 820. And since those are X values, I will use the mean of 840 and the standard deviation of 7.9. I have not been showing my work for possible z-scores for this particular question. So very unlikely to have one less than 840.